Hi everyone, welcome back to my channel Maths Shala. We are looking into the solution to RD Sharma exercise problems, and this video is going to be the continued part of exercise 9.6 of arithmetic progression chapter. So let us begin this video with our first question. Question number 13, which says find the sum of. There are multiple sub questions present in this main question. Let us look into them one by one. First question is find the sum of 2, 4, 6 and so on up to 200. In order to solve this question, first let us note down all the given data. Firstly, we'll note the first term of this sequence, that is A or A1, that is going to be equal to 2. Then we have last term that is denoted by letter L, that is 200. Now, using this information, we can calculate the common difference, that is D is equal to second term minus first term, that is 4 minus 2 is equal to 2. Now, applying the formula to calculate sum of n terms when we know first term and the last term, that is Sn equal to n by 2 into a plus l. Among multiple variables present in this equation or formula, we know first term A, we know last term L, but we do not know N. Means we need to know first of all how many terms are present in this sequence in order to calculate sum of all these terms. So first we need to calculate this N. For that we'll consider this last term, that is L, and we'll identify at which location this 200 is present. For that, an is equal to 200 now, and applying this formula, that is an equal to a plus n minus 1 into d, we will substitute all the known value and we will calculate this n here. That is an is equal to 200, a is 2 plus n we need to calculate, I'll keep it as it is, minus 1 as it is, into d. In place of d, we just calculated d to be equal to 2 here. Simplifying this equation, we get 200 minus this 2, we will get it on the other side, that is going to be equal to 200 minus 2, that is 198, and this 2 is will come in the denominator, that is 198 divided by 2, that will be equal to n minus 1 here. When we simplify this further, 198 divided by 2 is going to give me as 99, and when I solve for n, this minus 1 will come on the other side, that is going to be equal to plus 1. Therefore, there are 100 terms present in this sequence, that is n equal to 100. Now I know all the information to substitute in this equation, so I'll put all the values. Therefore, Sn equal to n by 2 into a plus l, where n is going to be 100 and this n I'll keep it as 100, and a, that is first term, we know that is 2, and the last term is 200, that is given to us. Simplifying this equation, we'll get 100 divided by 2 is 50, 2 plus 200 is 200. When I multiply this 50 with this 202, I get answer as 10100. Therefore, sum of 100 terms of this equation, this sequence, is going to be equal to 10,100. That is nothing but sum of this sequence. Next sub question of question number 13, which says find the sum of 3, 11, 19 and so on up to 803. First, let us note down all the given data. This question is exactly same as the previous question. First term is equal to 3 and the last term which is denoted by L, that is nothing but 803. And the common difference we can calculate by taking second term minus first term, that is 11 minus 3 is equal to 8. Applying the same formula again, Sn equal to n by 2 into a plus l, in order to calculate n, because we are not given n here in this question. First we need to calculate n by considering this last term as our an. Therefore an equal to 803. Applying the formula, an equal to a plus n minus 1 into d here. Substituting all the known values and solving it for n, I'll get n value as 101. Now applying same formula and substituting all the available values. Now we have n, we have a, and we also have l. Substituting all these values, I'll get s 101 equal to 101 by 2 into 3 plus 803, that is 803 plus 3 is 806. I'll divide 806 by 2, I'll get 403. Therefore, sum of 101 terms of this sequence is going to be equal to 40703. Next sub question of question number 13, which says find the sum of minus 5, minus 8, minus 11 and so on up to minus 230. This question is similar to previous two questions that we just solved. Let us look into this problem how we can proceed with this. First, let us note down all the given data. That is first term a or a1 is equal to minus 5, last term l is equal to minus 230. And we need to calculate common difference d, that is second term minus first term. Be careful here that our second term is going to be minus 8 and minus of minus 5, that is first term. Therefore minus of minus 5 is going to become plus 5 here. Minus 8 plus 5 will give me minus 3. Further, applying this formula Sn equal to n by 2 into a plus l, here we are given a, we are given l, and we are not given n here. So in order to calculate this n, first we need to find n value of using the last term, that is 230. Therefore an equal to minus 230, applying the formula an equal to a plus n minus 1 into d and substituting all the values here in this formula, we can find n. Solving this equation for n, we are going to get n as 76 here. Therefore, substituting this value in the formula, that is Sn equal to n by 2 into a plus l, we are going to get S76 equal to 76 by 2. A is first term, that is minus 5, plus l is last term, that is minus 230. Simplifying this, minus 5 minus 230 is going to give me minus 235. 76 by 2 is 38. When I multiply 38 with 235, I'll get answer as S76 is equal to minus 8930. Next question says find the sum of 1, 3, 5, 7 and so on up to 199. If you carefully observe, this is nothing but the sequence of odd numbers starting from 1 up to 199, and we need to find the sum of odd numbers up to 199 beginning from 1. Even this question is similar to the last three questions we just solved. Similar manner, we are going to go ahead with this question as well. That is, first note down given data a or a1, that is equal to 1. Last term is 199 and the common difference we know, that is a2 minus a1, that is 3 minus 1 equal to 2. Applying formula, that is Sn equal to n by 2 into a plus l. Here we don't know n, that is at which location this 199 is present. Therefore, in order to calculate that, I'll consider this last term as an and I'll calculate n. Therefore, an equal to 199. Applying this formula, that is formula to have the general term of an AP, that is an equal to a plus n minus 1 into d. Substituting all the known values, 199 equal to a, that is first term is 1, n minus 1 as it is, and d is 2. Solving this for n, I'll get n is equal to 100. Now we know all the terms present in this formula, so substituting all of them here, that is Sn equal to n by 2 into a plus l, where I substitute all the known values, that is 100 by 2 into 1 plus 199. Now simplifying this further, 100 divided by 2 is 50, 199 plus 1 is 200. That is sum of 100 terms of this equation is going to give me 10000. That is nothing but 10,000. Next sub question of question number 13 is nothing but question number 5, which says find the sum of 7, 10 and a half, 14 and so on up to 84. Here last term given to us is 84. Looking into this improper fraction, student feel it as difficult to solve, but this question is equally simple as we solved last four questions. Let us look into the solution how we can proceed with this question. First, let us note on the given data. First term is given to us, that is 7. Next, we need to calculate common difference D, that is second term minus first term. We'll note down as it is, second term as 10 and a half minus first term is 7. First, we'll convert this improper fraction to proper fraction by multiplying this denominator 2 to this whole number, that is 10. That is 10 into 2 is 20 plus this one, that is going to give me 21 divided by 2 minus 7. Now we know how to subtract these two terms when a proper fraction is given to us and that has to be subtracted using a whole number. In that case, we're going to take denominator as 2 as the LCM here, and 1 is multiplied to this 21 and 2 is multiplied, that is the denominator of this 21, and that becomes 14. 21 minus 14 is 7 divided by 2. Therefore, common difference of this AP is going to be equal to 7 divided by 2 here. Then applying the formula Sn equal to n by 2 into a plus L, we know last term that is 84 and first term that is 7, but we do not know n here. Like we solved in the previous problem, we'll consider this 84 as an and we'll calculate n means nothing but at which location this 84 is present. Therefore, applying the formula an equal to a plus n minus 1 into d, substituting all the available data in this formula to calculate n here. An is 84, first term is 7, n minus 1 as it is, d is 7 by 2, we just calculated here. Simplifying this, 84 minus 7 will give me n minus 1 into 7 by 2. 84 minus 7 is nothing but 77, and this 2 in the denominator will go to the numerator. 77 into 2 and this 7 will come in the denominator. Therefore, that is going to be equal to n minus 1. When I further simplify this, 7 and 77 can be cancelled here, or I can divide 77 by 7, which will give me 11. And 11 into 2 is 22. And this minus 1 will come on the other side, that is plus 1. Therefore, n is equal to 23 here, which means this 84 is present at the location of 23 terms from beginning. Now I know all the data that is required to calculate sum of n terms, that is Sn equal to n by 2 into a plus L. Substituting all the values here, I'll simplify this and I'll get final answer, that is sum of 23 terms of this sequence is going to give me 1046.5. Next question is question number 6, which says find the sum of 34, 32, 30 and so on up to 10. If you carefully observe this, this sequence is in descending order, which means we are going to get the common difference D as a negative number. Let us look into that. We are given with first term, that is A or A1, which is going to be equal to 34, and last term is given to us, that is 10 here. If we calculate common difference D as second term minus second term is 32 minus first term is 34. 32 minus 34 will give me answer as minus 2 here. Therefore, this whenever remember one thing, whenever we have a sequence which is in descending order, always that common difference of that sequence is going to be negative, because we are subtracting some amount in every number. That's why that is going to that sequence is in the descending order. Therefore, Sn is equal to an by 2 into a plus L. This formula we know. Again, we do not know n at which location this 10 is present. Therefore, again considering this 10 as an, I'll calculate n here. Substituting all the known values and solving it for n, I get answer as 13. Means this 10 is present at the location, that is 13th location from beginning. Therefore, applying the same formula again and substituting all the known values, I'll get answer, that is S13 is equal to 286 here. Now, coming to the last question of this video, question number 7, which says find the sum of 25, 28, 31 and so on up to 100. Even this question is exactly same as the all 6 previous questions. Same way we are going to solve this. Note down given data, that is first term as 21, last term as 100. Common difference as second term minus first term, which give me 28 minus 25 equal to 3. And applying the formula Sn equal to n by 2 into a plus L. Now we need to calculate n here at which location this 100 is present. Therefore, I'll take an as 100 and I'll apply this formula, that is an equal to a plus n minus 1 into d, and I will calculate, or I will solve this formula for n. When I do that, I am getting n here as 26, which means 26th term is 100 in this sequence. Therefore, substituting all the values here in this formula, that is Sn equal to n by 2 into a plus L, I will get answer as S26 is equal to 1625. Hope you enjoyed this video. Stay tuned for the next video. In next video, I'll come up with next part of exercise 9.6, which will be the continuation of this exercise 9.6. Thank you for watching the video. Please like, share, and subscribe this channel for getting all the updates on the new videos that I'll be uploading. Thank you once again.